Hi, my name is Ajin Kubari and today's topic is Nyquist plot and board plot for stability analysis. So let's look at our group members. Durgesh Sisat roll number 56, Ajin Kubari roll number 59, Shreyas Wadne roll number 68 and Aniket Sonavne roll number 70. So let's dive right into it. Let's look at the code. This MATLAB code generates a Nyquist plot for given transfer function g of s equals to 1 upon s square plus 0.8s plus 1. So let's break down the code. First, num001. This line defines the numerator coefficient of the transfer function. In this case, it represents s raised to 0, s raised to 1, terms as zeros and s square as 1. Then 1, 0.8, 1. This line defines the denominator coefficients of the transfer function, representing s raised to 0, s raised to 1 and s square. Terms as 1, 0.8 and 1 respectively. Nyquist num, den. This function generates the Nyquist plot for the transfer function defined by the numerator and denominator coefficients. Grid. This command adds a grid to the plot for better visualization. Title. As you can see, Nyquist plot of g of s equals to 1 upon s square plus 0.8s plus 1 sets the title of the plot. X label is real axis and y label is imaginary axis. These commands label the axis and y axis respectively. The x axis and the y axis respectively, indicating the real and imaginary axis. Hold on, the last command of the code. This command tells MATLAB to overlay subsequent plots on the existing one, allowing multiple plots to be displayed simultaneously. In summary, this code generates a Nyquist plot for the given transfer function and adds a label, a title, and grid for clarity in the visualization. Thank you.
So, after we successfully run the program, here we are having the output graph. So first of all, we will use the transfer function g of s into h of s equals to 1 upon s square plus 0.8s plus 1. So with the help of this transfer function, we will find the omega, and afterwards we will get the omega which is negative, which is imaginary, and which implies that it will not have phase crossover, and it will not intersect with negative real axis. And after that we will find the omega at different 0 and infinite frequency, at different 0 and infinite frequency. And after that we will get omega equals to 0 and magnitude equals to infinite, and then we will get omega equals to infinity and magnitude equals to 0, and phi we will get minus 180 degree. And afterwards that we get to know that the polar will be from minus 90 degree to minus 180 degree.
Myself Seshwadne. Today I am going to explain how to write a program for board plot. First is objective. First objective is to draw the board plot in the given system. Second is find the optimum value of the frequency where the system is stable. Third one is find the values of GM. GM means gain margin and PM means phase margin. Next, what is meant by board plot? A board plot is a graph of the frequency response of the system. It is usually a combination of a board magnitude plot is expressing the magnitude usually in decibels of the frequency response, and board phase plot expressing in the phase shift. Next, we have to learn program for board plot. So in this slide, the numerator value of given is in bracket 1 0 2 3. Next is denominator gain, so equals to in bracket 666. Next, gain of s, g of s means gain of s. Then u equals to tf. Tf means transfer function in bracket numerator comma denominator. Next line board of in bracket u. Then grid, then hold, and the title of the board plot in bracket board plot equals to g of s and equals to s raised to 3 plus 2s plus 3 denominator s raised to 5 plus s raised to 4 plus s raised to 3 plus s raised to 2 plus s plus 1 bracket complete. Then in bracket gm GM means gain margin, comma PM means phase margin, and comma WCP bracket complete equals to margin U. Then gain margin minus decibel plus 20 into log 10, and in bracket GM gain margin in bracket complete. So in this way you have to write this program. Thank you so much.
Everyone, myself Nyquist Sonone. After successful bond plot, we can see there are the two output. First one is frequency to the magnitude, and the second output is frequency to the phase. In a first, magnitude is on y-axis and frequency is the x-axis. In their second graph, we can see that x-axis is a frequency and y-axis is a phase. The bond plot is a the bond magnitude plot is expressed by the magnitude, and second one is a bond phase plot is expressed by the phase shifting.